Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we continue with chapter 8, which is the rotational molding, also known as the casting for rotomolding. Okay. So here the lesson outcome for this chapter. By the end of this chapter, you should be able to describe the process stages involved in the productions of the rotomolding product, differentiate between this product fabrication process and the other product manufacturing process and the raw material requirements, and finally explain the processing and product features of these types of manufacturing technique. So basically, there is only one technique for this rotational molding. So the different industry, they might probably have a multi-cavity, okay, the other variation is the capacity or the size of the mold they use in the industry compared to the one that we have in the lab. Okay, so what is rotomolding or the rotational molding? Molding process for creating many kinds of mostly hollow item, typically of plastic. So basically, the rotational molding producing a hollow item, although they can produce solid parts of the product. However, they commonly used for hollow parts and usually involved with the usage of plastic material. And then the rotomolding or rotational molding is a method that involves the slow tumbling, heating, melting of the plastic powder in a biaxial rotating mold to produce seamless hollow plastic parts. So during the process, they involving the tumbling, heating and melting. Okay, so this process is typically used to mold hollow parts, especially those with complex and varied shapes not easily obtained by other hollow art process. So some of the technique might having a difficulty to produce hollow parts. So we can consider using the rotational molding for producing the hollow parts with complex what we call that shapes and design. It is virtually shear-free and pressure-free process. The wall thickness, uniformity, and the part width can easily maintain. There is a very little waste of material due to scraps. Rotomolds are often less expensive than other types of molds. Okay. Stage 1, okay, the process of the rotational molding divided by 3 stages. Okay, I assume 3 stages up to 4 stages. Okay, the first one, the loading of the material. A predetermined amount of resin is loaded into the mold. So you need to wait your raw material to be inserted into the mold cavity. Again, and of course, it depends on the types of material. At the same time, the thickness that you want to produce the final products. The mold is closed after the flange have been cleared of resin particle. The mold is secured shut and then rotates the mold to ensure no tool have been left on the machine. Okay, so you try to move or rotate the mold to ensure it is easily movable. Okay, and then the stage 2 is heating process. Okay, rotate the mold biaxially in high temperature of environment up to melting temperature. Okay, so biaxial is two directions of the rotational. Okay, so the y and the x axis rotation. The rotation is biaxial along major and minor axis. It will slowly coat the mold interior until all the resin has melted and flow all over the surface. And then the resin will then continue to densify as the gap between the particles disappear. Remove the mold from the oven when the powder has completely melted and densified. So whenever you heat up and the material start to melt it and start to flow and the melted start to densify, and then you remove the heating process. Okay, so you remove the mold from the oven or the heating elements. Okay, and then you go to the cooling. Before that, the length of time a mold spent in the oven is critical. Okay, this need to take a precaution. This is the very important parameters that need to take into account to produce a good rotational molded product. Okay, too long and the polymer will degrade, reducing the impact strength. If the mold spend too little time in the oven, the polymer may be incomplete. The polymer grain will not have time to fully melt and coalescence of the mold wall, resulting the large bubble of the polymer. Coalescence ni ialah dia dia tak boleh melapisi lah apa dia punya mold cavity tu. So apa dia jadi satu bubble ataupun blob, so dia akan rotated saja. Okay, so at the end of the day bila awak buka mold, dia masih dalam bentuk satu blobs, so dia tak ada jadi hollow parts. This has an adverse effect on the mechanical properties and the finished product. Okay, the stage 3 is cooling I mentioned earlier tadi. Rotate the mold in a room temperature environment. After immediately you remove from the heating element or the oven, you still keep on rotating the mold at the room temperature or the environment temperature. This allows the layer of resin to cool and solidify. Okay, this is the process of solidification and the cooling process. Water can also be used, but care should be exercised. Okay, there's some drawbacks using water, although you can dramatically and reduce the temperature and solidify the molten polymer faster, but there is some drawback. Later on I will go through about this. Cooling the mold usually by fan. This stage of the cycle can be quite lengthy. Okay, in our labs we use the fan technique. The polymer must be cool so that it solidifies and can be handled safely by the operator. Okay, this typically takes tens of minutes. The parts will shrink on cooling, coming away from the mold and facilitating easily removal of the part. The cooling rate must be kept within a certain range. Very rapid cooling, for example, water spray, would result in a cooling and shrinking at an uncontrolled rate, producing a warped part. This is the drawback of using the water spray, the water cooling. Okay, you promoting a rapid cooling, okay, and resulting in shrinking and at uncontrolled rates and producing a warp parts. Okay, stage 4, the unloading. Okay, after the cooling process, the unloading or removal of the parts lah. So remove the clamping system. So you open the mold, lift the complete hollow one piece part from the mold, and cycle can be repeated. Okay, this is the illustrations of the rotational molding. You put the raw material, you close the mold, you introduce heating, allow the material to melt, and then you rotate. You rotate, and the molten polymer cover up the internal parts of the cavity as you allow it to solidify using during the cooling process. The product can easily be removed. So this is other illustration. Material put into the cavity, heat up, allow it to cover the internal cavity. Once it cover, you allow it to cool. Okay, once it cool, you open the mold and then you remove the parts. Okay, basically that's the only process involved during the rotational molding. So this is the 2D illustrations of the rotational molding. The first one, charging the mold, which is to put the raw material that you already with. Okay, and then you close the mold, you introduce heating process. Okay, at the same time, the mold rotated biaxially, which is the X and Y axis, and then the C is the cooling process. Also during this process, the mold still rotated biaxially, and you introduce the cooling methods, cooling media, which is either the air or the water itself. And then once the parts is solidified, mold is open and part is removed. Okay, this is other illustration, not worry to this. Okay, this is one station of the what we call that, the rotational molding. Okay, initially the number one is the load and unload station. Okay, you put the raw material, okay, and then once you clamp the mold, okay, you go through to the heating station. Okay, during this process, the mold is rotated biaxially. Okay, as the as the material start to melt it. Okay, So you will remove from the heating station, you go to the cooling station, and mold still rotated biaxially. As the polymer melt starts to solidify, it go through to the unload station, which is the mold is open, part is removed, and the next cycle, which is the new raw material, will be loaded into the mold cavity. Okay. So this is the illustration, the bigger illustration for the major and minor axis. Major axis rotated at the y-axis, which is the minor axis rotated at the x-axis. This is the other illustration. I think nothing much to worry about this. I already explained that one. Okay, this is the image taken from the industry itself. So if you can see here, each of the station have two mold, so multi-cavity mold. Okay, multi-process. So once the mold is loaded with material, okay, it will go through the heating station. Okay, once the material start to melt it, and then the mold rotated again, go to the cooling station, and finally go through the load and unload station. Okay, this are the angle of the illustration. Usually these types of rotational molding is a bigger scale in industry. The key processing parameter, this is very important for the key processing parameter. The heating time should be long enough to make sure the mold has picked all up the powder in the powder pool. The heating temperature should be kept to the temperature where the material can become tacky enough to sinter without degrading the polymer over a length of the cycle. So you need to know the melting temperature of the raw material itself, the material you use to produce your final products. So you don't want to introduce excessive heating. It will start to degrade the raw material, or underheating, which is the low temperature, will promoting more defects. Okay. The speeds of the rotation on the two axes is important to ensure full coverage of polymer in the mold. So actually, the axis, the major and the minor axis of the rotation can be adjusted, depends on the material you use, the dimensions of your final products. Okay, is it complicated parts or the simpler parts, and then depends on the thickness variation that you want to produce, sir. Okay, the mold is cooled by fan blowing air on the mold. When it cool, water is sprayed on the mold to finishing cooling. Okay, this is two stages of cooling. The first one, they use the air blowers, and then they spray water. Water is not used right away because it could warps the mold. Okay, this is very important. So you don't want to introduce water spray immediately after you remove the mold from the heating station, because it will harm or warps your mold, and at the same time the material will start to rapid shrinking. Okay, and producing more defect onto your final parts. The times to cool the mold is depend on when the part can be removed from the mold without deforming. Advantage and disadvantage of rotational molding. Okay, for advantage, it is low pressure process as compared to other types of molding process to produce hollow parts, such as the injection molding itself. Thicker corner and stress-free product. Very large product it's possible to be made using a rotational molding. Low mold and equipment cost as compared to other techniques. Easy color and resin changes. Okay, easy mold changes also. But the disadvantage, limited to simple shapes only. More complicated parts are rarely being used using rotational molding. Poor dimensional tolerance. Okay, because dimensional stability currently a little bit hard to be controlled during the process. Wall thickness is usually non-uniform, as I mentioned earlier. One side appears smooth, okay, which is the outer appears smooth as compared to the inner. And then the slow process cycle, which is longer cycle time, because the rotating process, the heating process involve time consuming. Same goes to the cooling process. Low part and product mechanical properties. Okay, feature of the process. The thickness of the product will be depending upon the quantity of the material placed inside the mold. So the more the material, the thicker will be the molded parts. Okay, the rotated molded parts. The variation of thickness is the distribution depending upon the rotation speed. Okay, as is the major axis or the minor axis, depends. If the major axis is rotated faster, so might probably the top and bottom thickness will be slightly thinner as compared to the side wall of the product. And then the molding cycle time will be very much depending upon the size of product to be made. Okay, normally range from 5 to 30 minutes. And the cost, low tooling cost and high piece price are typically of this product. Okay, cycle time average around 40 to 45 minutes for one single parts. Okay, in terms of raw material, lower viscosity material are typically used in this process as they are more readily sintered. To ensure a good surface finish, it must also be able to adhere to the whole surface of the cavity and fuse together without a pressure, because it is a pressure-free molding technique. Okay. The raw material that commonly used using rotational molding commonly is the PE, polyethylene, either the LDPE or the LLDPE, because you don't want high density material. And then we use polypropylene, and then we have EVA, ethylene vinyl acetate, and also PVC material. The current area of usage, if you can see here the image of the water tank, okay, also sometimes of the chemical tanks, and then some of the housings, playgrounds for children's, and then we have also one-piece kayaking sport equipment, okay, and then other casings for electronics devices, etc. And then this is the common method, which is the LDPE, custom rotational molding, involved of the what we call that the bottles, okay, storage for the automotive industry. This is the either the water storage or the chemical tank itself. Okay. Other than that, also we have external external use of plastic material, such as the cone, the pots, the playgrounds, the rubbish bin, etc. Okay. Also a playground for children's. The common product that been used using rotational molding is the cone itself. Okay, if you go to the streets, if you find out you encounter this cone, although the cone size is slightly bigger, okay, but actually the weight is very lightweight because of the hollow parts. This is the water tank and chemical tanks. Okay, completing process, extrusion and injection molding, completing process. Other than types of extrusion, the rotational molding, there is two other techniques that have been used to produce a hollow part. The first one extrusion, the second one injection blow molding. Part made with blow mold will have higher tolerance as compared to rotational molding itself. Typical cycle time would be a fraction of the rotational molding cycle. In extrusion blow molding, the largest part is 1,000-gallon tank. Okay. It is possible to make bigger parts with rotational molding. So the best advantage is the rotational molding. You can mold it a bigger parts. Okay. In conclusion, though in the state infancy, rotational molding offer unique advantage over other plastic processes. There are endless opportunity for research and development. Rotomolding has a very promising future, more so than many competing process. So that's all for this chapter 7. I hope to see you in chapter 8 and 9. By then, Assalamualaikum warahmatullahi wabarakatuh. Thank you.